Hi everyone, let's start with new question from 46 to 50. Consider the following statement and find the correct answer using the code. Assertion: the observed magnetic moment of the copper to acetate monohydrate is 1.4 bm at room temperature as opposed to spin only value of 1.73 bm. The complex region given is the complex is a dimeric one, and due to weak copper direction there is a partial quenching of the spin magnetic moment. Now for this kind of factual questions, the one which we can calculate, we should check, verify that, then we should go through. Suppose you see spin only we can calculate, right, for copper 2. So let's check that one. If it is right, then we can go further. Suppose copper 2, right, copper 2 means D9 means 1 unpaired electron, 1 unpaired electron. It means, as in the last video we have seen the trick. So trick, if we calculate in this way, n plus 2, for 1 it may be easy, right? 1 plus 2 plus 3 to 3, right? We can, for this we can calculate, right? But we'll use a trick, right? The trick is, what you do, write the unpaired electron and put on 8, right? I have told you in the trick in the last video. You can check it there also. So it is nearly 1.8, right? You can be, means it will be just nearer value. So it is right, it means this is right. But the fact this value is this is less, right? 1.4 at room temperature it is 1.4, but the spin value is this one. The reason is given copper. Yes, this is true that copper interaction is weak, so there occur a quenching, therefore the value become less, 1.4. Therefore the both this one and this one is correct. Both assertion and reason both are true, and R is the correct explanation of S. This will be the answer. But you see what happened here, copper acetate, right? Copper acetate, it form a dimer. Actually they form a dimer that leads to there occur means they form a dimer, right? Then there is a weak copper interaction between them. As a result the value decreases. You remember this, okay? Structure dimeric form like this is copper acetate, right? Or acetate means CO acetate, right? This O will connect to another Cu in this way, but there is no connection in between the two. But this distance is nearly the normal copper distance. So there is a weak copper interaction between them. Okay, there's a weak copper interaction between them. So you can draw other also in this way. Now for this copper FM, from this you can draw one more. Suppose from here O, C, not draw C, bone line structure, C, O. In this way you can go. For this also you can draw O, for this, and then sorry, this will not attach here, this will attach to another copper, right? In this way it will go. Similarly you can draw here dimeric form you can draw, right? So you can see this structure is important. For example, what new it will ask, this structure is important. How many CO bond are there? This may be asked, okay? This is important. Structure, it may be asked. Structure, it is distorted, right? The structure will be asked. This is the important part. Next you see this question we have already discussed in the last video. Please comment. We have seen the trick also, right? Please comment in the comment section for this answer. Okay, we have in the last video we have explained the trick how to solve. Okay, very easy trick to remember, right? Next you see, give the answers in the comment section. Next 48, true or false. You see, ferrimagnetic behavior is shown by Fe2O3, antiferromagnetic behavior is shown by Fe3O4, and paramagnetic property is temperature dependent, and this complex is diamagnetic. Now these two we cannot solve, right, directly. If you know the example, then you can do, right? But these two we know, right? Paramagnetic property is temperature dependent. This is true, right? As we know that magnetic susceptibility Xm is inverse proportional 1 by T, right? This is the relation we know, right? Therefore we can say this means Xm is equal to C by T, right? So therefore it is temperature dependent, right? For paramagnetic this we know. So this is true, C is true, so we can see that C is true, these are true, right? This is true, right? These two are true. Now this one we can find how much Fe is dimagnetic. We can see Fe Cn6 4 minus. Now we can do X, we can oxygen state plus 6 into Cn minus 1, right, equal to minus 4. How much we'll get? X minus 6 equal to minus 4, X is equal to 2. Means oxygen state 2 means Fe2 plus means 3d6 4s2, right? 2 1 2 no 2 1 d6. D6 means you check the unpaired electron. D6, this is strong field again, right? Then 1 2 3 4 5 6 pairing, no? Strong field pairing. So there is no unpaired electron, so not paramagnetic, therefore it is dimagnetic. So the addition is given in dimagnetic, means these two are true. 3 and 4 is true, 3 and 4 is true, 3 and these two true. So therefore the answer will be C. In this way you have to solve everything. It's not possible that all the options you know, right? You see this ferromagnetic behavior is shown by this one, Fe2CO3. You see Fe3O4. Fe3O4 is magnetite, right? You remember this. Magnetite is Fe3O4. Other example like chromium oxide, CrO2, Mn arsenide, and Nd2Fe14 boron B. These all are magnetite. These all are ferrimagnetic. Remember this. These all are ferrimagnetic. Achha. What should you learn from this topic is that first of all, diamagnetic, you know that KMnO4 very important. KMnO4 is diamagnetic, right? KMnO4 is diamagnetic, but slightly paramagnetic character, and is independent of temperature. Right? What is the reason? Reason is that the energy gap between HOMO and LUMO is less, therefore. Okay, so remember, for diamagnetic it is independent of temperature, for paramagnetic dependent. Okay, for paramagnetic inversely proportional to temperature, right? And for ferromagnetic it is all are aligned in the same direction, right? For ferrimagnetic, alignment is also important. 2 up, 1 down, 2 up, 1 down, in this way to go. And for antiferromagnetic all cancel each other, right? Up, down, down, in this way. Okay. Now you should remember other molar magnetic susceptibility concept, like for paramagnetic For paramagnetic, as I have already told, xm is inversely proportional 1 by t. So xm equal to c by t, right? What is c? C is a Curie. C is a Curie constant. C is a Curie constant. For diamagnetic, it is what? Independent, right? Independent of temperature. And for ferroferi, antiferromagnetic, it is xm is equal to c by 1 minus theta. And got ferro and ferri, theta is positive. For antiferromagnetic, theta is negative. And what is theta? Theta is nothing but is a constant with same unit of temperature, right? Now one more thing you have to remember, the graph you should remember, very important. xm t, as we know, this is for what? Independent, right? This is for diamagnetic. This is for inversely proportional, right? Temperature. So this is paramagnetic. Next, if you see this goes up again down, this is antiferromagnetic. And for this is for ferri and ferro, right? You have to remember this. And this temperature, this you see, this is nil temperature, right? This is Curie temperature, right? Now it acts as a this antiferromagnetic, this acts as a paramagnetic, right? Below nil temperature. Now you see another example, another diagram. You have to remember t versus xt, xm, t versus t. This will be paramagnetic. This is, you remember. Another important is, I have no page here. Another important diagram is this 1 by xm versus t. You remember, this is antiferro, this is paramagnetic, and this is ferro or ferri. Okay, you should remember these. Okay, this part you should remember. These are the concept from this one here, from this one. And let's check the next question. 49, we see the oxidation state of the iron. This complex is +2 and is blue in color. So given that both NO and H2O can act as electron donor, also the color is due to the left proton and spin allowed transition, means transition. Color is due to transition, they are saying. Now you see this complex, we can calculate +2 or not. We can check, always check the data which we can find. We should calculate and check, verify it. So suppose the complex is FeNO H2O whole 5 2 plus. This complex, if you remember, this is a ring test, right? Ring test for nitrate, right? This complex is for ring test for nitrate, right? Nitrate, NO3- for nitrate, right? So this complex, a ring test. Do you know what is the color? If you know, yes, you may remember, this is a brown ring test, right? You know it is a brown ring test, right? So already it's given blue, this is wrong, already false, right? And then +2, let's check +2 also. X plus O, +1 for NO, +5 5 times 0 for water neutral plus 2, we'll get x plus 1 is equal to 2, x is equal to plus 1. 1 it is given here, it is 1 we found here, it is 2, it is also false. You remember this, for if the complex is means if the coordination number is 6, the NO exhibit is plus 1 oxygen state. Remember this, if the coordination number is 6, then you take NO to be NO2 part, right, one linear, one band, right? So NO you consider plus 1. Okay, that's it. Next, you see here it is given that the color is due to the left rotate and spin forward. Now you see, as the oxygen state of the metal is low, right? So it is what? MLCT, right? It is due to MLCT, not the rigid transition, right? Okay, this is very important. Next question you see, so the both are false, right? So it will be D. Next you see, next 50 question. This is from quantum, right? The Huckel molecular theory, the Coulombic integral is assumed to be have same for all the carbon atom in a molecule. This is true. If you doesn't know this also, you see this, you can solve this too from this too also. You see the overlap integral as between any two atoms is assumed to be 0 in any situation. So you know the one formula, right? Ca square plus Cb square plus twice Ca Cb Sab equal to 1, right? This Sab is what? Overlap integral, right? Overlap integral, right? Therefore it is always 1. Therefore it cannot be 0. So this is false. So this is false. You can see this is false. This is false, right? This is false. This is false. No, sorry. Number 2. Now this is false, and this is false. 2 and D, right? Next you see the ground state of the benzene is associated with the 2 non-degenerate and the 2 doubly degenerate energy level. Now benzene, we will draw the Frost diagram. Benzene, you see, right? Benzene structure we know 2 to 4 is 6 electron, right? 2 to 4 5 6 electron. So if you feel 1 2 3 4 5 6, right? Now actually question is it should be false according to the statement, but they are giving is true. You can see as ground state it mentioned, it means we have to add the electron also, right? If we add the electron, we see that there is only this is non-degenerate, right? This is non-degenerate, this is doubly degenerate, right? This is 2, there is 2 doubly degenerate. So 1 non-degenerate and 2 doubly degenerate it should be. But if you see here, the 2 non-degenerate and 2 doubly degenerate, but they are giving that it is true. They are considering as a whole. You can see these 2 are non-degenerate and these 2 are doubly degenerate. In this way they are considering, but this is actually, this should not be true. It should be false. So now you see, if you consider a ground state, then electron should be added, right? Then electron, when we add the electron, if you see here only in this part, there is a doubly degenerate, 2 doubly degenerate, right, and 1 non-degenerate. So this should be right, but they are giving true. They are considering as a whole, these 2 together, these 2 together. Okay, so similarly you should know for this one also, cyclobutane also, you draw in this way, right? In this way, right? This is important, right? This type of compound. Frost diagram from Frost. Next, energy. Next, you see the energy level of the naphthalene are all degenerate. Here the energy level of naphthalene is naphthalene means 2 benzene fused, right? 2 benzene fused, right? 2 benzene fused, right? So here if you see the MO diagram of naphthalene, you can see the all are non-degenerate, right? All the energy level are non-degenerate. So this is false. So 4 is false. 4 is false. We can find this is true. This is false, right? There is given 0 now. It should be 1, right? And then automatically this is true. So the answer will be B. So Thank you so much. We'll come in the next video.